Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course that thinks it's in an autonomous collective. I'm James Messer, and in this module we're going to talk about the second part of our Addressing Technology series of videos on subnet masks. This comes to us from our N10-004, section 1.4, where we need to learn about addressing technologies, and we're going to talk about just about the subnetting aspect of the section 1.4. We're going to look at subnetting the network. And here's the question you'll often hear is, why would you want to even subnet the network? From this module, we're going to talk about taking an entire view of the network and figuring out how to split it up into smaller pieces. Our previous module talked about the subnet that we happen to be on as a single device. But as a Network Plus professional, you may be asked to come up with an entire IP address numbering scheme for every network that you happen to have in your organization, which means you have to think about how many segments do I need, how many different networks are there going to be, how many different hosts per network do I need, and you then need to figure out what your subnet mask scheme is going to be based on restrictions that might be placed upon you. And the restrictions placed upon you may come directly from the people who give you your IP address. Your IP addresses may be assigned to you, either internally in your organization, or they may be assigned to you by your ISP, which means they'll give you an IP address or a range of IP addresses, and they'll say that's all you get. That's what you're going to use to talk out to the internet. And then you're going to have to find a way to either use what they've given you or split it up into smaller pieces or subnet it out so that you could spread it around your network. And the questions you'll ask about is, how many networks do we have in our environment, and how many hosts on each network are we going to have? And that's going to help you make a decision about how you're going to subnet things out. So let's say that your ISP or your internal network department, maybe you're at a remote site, has said, you've got an IP address that we're going to give you. Your network is 192.168.1.0, and your subnet mask is 255.255.255.0. Or they may just say your network is 192.168.1.0/24. That's the CIDR block notation we were talking about earlier. Those are exactly the same thing as you recall from our previous video, but they may just give it to you in an email and say, here's your network number. It's this 1.0/24. The problem is that we have one network, two networks, three networks, four networks here, and they've given us one IP address with one subnet mask. And that's a problem because we need an IP addressing scheme that allows us to use more than one network address. We're going to have to take what they've given us and split it up into smaller pieces. We're going to have to subnet our network. So let's bring up a chart then. If we're going to have to start subnetting our network, we could sit down and do all the binary calculations ourselves and spell out all the subnet mask possibilities and do the conversions. But fortunately, someone's already done that for us, and there's plenty of IP address calculators out on the internet. Here's the sneaky little story, is that we have to know how to do this calculation for our exam. But in the real world, we just grab a calculator or a subnet calculator, type in what our IP address is and our subnet mask, and have the calculator tell us what's our options. What can we do? And here's a chart that does exactly that. The subnet mask they gave us was 255.255.255.0. Here it is. And that means we can have one network and we can have 254 hosts on that network. Well, in our scenario, we need at least four networks. And if we look through this list, we can see there is a subnet mask 255.255.255.192 that is a CIDR block notation of /26, exactly the same thing. That allows us to have four networks, but we only can have 62 hosts on each network. See, there's a trade-off there. When you steal bits from one side, you give bits to the other side, it's a trade-off. So as long as we don't have more than 62 hosts on our network, we're okay. So let's figure out how they came up with that number. Let's take this, and if you saw our last video on looking at this number, this should look familiar to you, where we've just taken the IP address and the subnet mask and we've written it out in binary. Now, one of the things I did, because the subnet mask they gave us was 255.0, but we're thinking of taking and changing that subnet mask to 255.192. So on the two places where we stole a couple of bits, we took two more bits out of what they gave us to create a subnet of the IP address they gave us. So I've identified that with this S, so you'll know this purple S is our subnet. And that's how we came up with these 4 networks and these 62 hosts per network. Is we wrote it all out and said we're going to use these 2 bits as these 4. In fact, if you look back at the calculations, you know you can only come up with 4 different options if you only have 2 bits available to you. And if you've got 6 bits available to you, the most number of devices you can have is 62. That's exactly where these numbers are coming from. So there's no mystery here. All we're doing here is a binary calculation to determine the number of networks and the number of hosts available to us. Now, if we write this out long ways, you can actually see it. From a binary perspective, 0, 0, here's our subnet, 0. 0, 1, if we have the 0, 1 and then a bunch of zeros, it's 64. 1, 0, 0, 0, 0, 0, 0 is 128, and 1, 1, 0, 0, 0, 0, 0, 0 is 192. So you're going to see these numbers also pop up. Those are our 4 subnet values that we're going to have associated with this network. And if we take all the brown host numbers and we calculate between these zeros and ones, it happens to equal the numbers 0 to 63. So there's the range of subnet values and host values that we're going to be using here. Let's start putting these together to see what they might look like. And if we write this all out in long form, I know there's a lot on the screen here, but this is the process that you would normally go through if you didn't have a subnet calculator, is you take each example. We have 192.168.1.0. We're going to use 26 bits of a net mask, and we've spelled them all out here. I've written them all out long ways so you can see all 26 bits. And we know that we're going to have 62 hosts per net because we've done the calculation with those 6 bits that are available to us. Now, our first network is going to be all zeros. So we'll put a 0, 0 here, which means if we were going to write it out, and if you remember back looking at how we calculate our subnet and how we calculate a broadcast, we know our first network is 192.168.1.0/26 because we just wrote that all out. If we made it all ones down here, again, that process we did earlier, that's our broadcast address. And if we look, that is 192.168.1.63. We've just taken those 4 numbers and converted them back into decimal. That means that if we have a minimum and a maximum number of hosts, we take everything in between, which means we put a 1 down here. That's our first host on the subnet. And everything but all ones, we leave the last one off because that's our broadcast for our host. So the first host we would have on that subnet is 192.168.1.1 and 192.168.1.62. Okay, that's our first subnet that we've broken out of the 4 that we're going to create. To do the next one, we go to our next value for the subnet. We'll take the purple numbers and add the next value, which is 0, 1. Once we've calculated those out, we take the next binary value, which is 1, 0, and then finally the binary value 1, 1. And that's how we come up with those 4 subnets. We perform the same network calculation, the same broadcast calculation, the same host minimum, and the same host maximum. Now that's a lot of binary calculations, but that's it. We've now done the calculation to determine, based on the IP address and the subnet mask that we have available to us, what the 4 networks are, what the 4 broadcast addresses are on each of those networks, and what host IP addresses can exist on each of those 4 networks. And we're done. Even though they gave us one IP address from our corporate office, we were able to split it up into smaller pieces and distribute it out on our network. And if we look how we put this out here, on one router, we'd have a network 192.168.1.0/26. We have a 192.168.1.64 network /26, a 128 network /26, and a 192 network /26. And that's how we would distribute them out in our local remote site from that single IP address they gave us from our corporate office. And it's just that easy to sit down, lay it all out, map it out, and see how can we create this IP addressing scheme for our local network and implement it in our environment. That's a lot of binary calculations for one video, but now we've taken the idea of the binary math we did before and we just applied it over and over and over again from the perspective of an individual workstation all the way out to doing subnetting of entire networks that we did in this video. So let's see what we learn. Let's take this idea. Is the IP address 192.168.1.88 in the subnet 192.168.1.0/26? Well, if you still have your notes or you want to back up a little bit and look at the charts that we just did a /26 subnet. So we would know that this is not, the 1.88 is not in the 1.0 subnet, because we know that we only have the devices .1 through .63 in that individual subnet. So we know that it's definitely not one of those. If it was on this subnet, it would have to be 1 through 62. Our 63 is our broadcast, our 0 is our subnet value. So let's do another one. Our 10.1.22.5 is that IP address in the subnet 10.1.0.0/16. Well, we did one of those in that same subnet mask in a previous video, and if you remember, that certainly would be because the value of IP addresses in that subnet are 10.1.0.1 through 10.1.255.254. That's a lot of devices on a single subnet, over 65,000. But there are some networks that are subnetted like that out there in the world. Even if you don't use all 65,000, the subnet may still be set up that way. How should you subnet a network then that needs 6 networks and it needs at least 20 stations per network? What subnet mask would you use? How would you subnet that out? Well, what we should do is go back to that calculation, that big chart that we had, and look to see what's there. We need 6 networks with at least 20 hosts per network. Now, we know that we're 4 networks in the one that we used. That's not enough networks. So the next one up is 8 networks. This subnet mask of /27 would allow us up to 6 networks and even a couple for spare if we wanted to use that later. But remember, we need at least 20 systems, 20 devices on each one of those subnets. Does it match that? Well, if we look, we can see the number of hosts per network is 30. So that's over the value we needed for 20. So if we needed a subnet that had those particular parameters associated with it, this is the subnet we'd use with a subnet mask of 255, 255, 255.224, or if you want to write it in the easier CIDR block notation, it's a /27. And we'll add that into our list. That's exactly what we would use if we needed to subnet a particular network out. Hopefully that's given you an idea of what you can use and the process you would go through to perform some subnet masking on your network. And now we know everything we need to know for that section 1.4 of our Network Plus exam. For more Network Plus videos, to participate in our message boards and much more, you can visit our website, freenetworkplus.com.